All right, so it looks like we picked IF9, compare properties of two functions, each represented in a different way, algebraically, graphically, numerically in tables, or by verbal descriptions. Can we go ahead and start with identifying verbs and important nouns?
Perfect.
Great.
Yeah, so here compare is
That's our key verb
Yep.
in there.
our most active verb.
Oh, is that the only one?
And that is the only one,
Yes,
Oh.
it is.
which might simplify our shows.
And then what about the nouns?
So we have properties is really important.
Okay.
Functions
Functions.
is going to be really important. Yeah.
Do we have to put, what
Um,
about two? Do we have two functions? Is
Well,
that
you have
important?
to, isn't it, I think maybe
It is
that's
it is
implied.
inherent to comparison
Yeah, because you
that
need
you would
two to compare.
to.
Okay.
It's represented in a different way.
Do you,
And
do
then
you
we
think
have a
we
list
could
of
just,
ways.
yeah,
I
do you
think we
think we
might
could just underline these?
underline the
Yeah,
ways.
algebraically, graphically, numerically. And then tables, yeah, and verbal
Numerically
descriptions.
tables
Yep.
and yeah, perfect.
All right, great.
All right.
All right, so thinking about the conceptual knowledge that we need for the no, what properties of two functions?
Properties of two functions. What are the properties?
Okay, so when we're comparing two functions, we should compare. So I might say something like the properties of a function include um, the rates of change, the family, like
Rates of change,
rates of change,
okay.
the family, the maxima or minima, the intercepts,
Minimum.
M-I-N-I-M-A.
Okay.
the intercepts, rates of change, family, maxima, minima, intercepts, and the I'm going to say and direction.
Okay.
Thanks for being so specific on that. That helps, like in the communication process and our clarity and what we.
I know I'm already
Think it's
thinking
to know.
like, how many,
Yeah, these are separate.
I'm already thinking like, here's some of the content vocabulary that we would need to include
In our
Absolutely.
vocabulary section in our.
unit planner.
Mhm.
Okay,
So that covers properties, functions, and this is another thing that points back to that like content vocabulary.
mm-hmm.
A function is a set of inputs and outputs and follows rules.
Inputs
Inputs and outputs.
that follows rules.
And I think that it's appropriate to be shorter here because this is the like function of quarter one in our curriculum materials, defining what a function means. So students should be familiar with this, and we'll just be like going back to that for a second to say we're back to functions and we're now comparing.
I was looking at the no-show unpacking the standard cheat sheet, and for the no side, it really talked about like the what and then the purpose. So if I was explaining the purpose of a function, what do you think that we would tell kids to help them understand? Like make it relevant.
I would say that a function communicates the relationship between
Ooh.
an input and an output.
Is that a separate no? Or is it just continuing on the same one?
I was going to continue it on the same one, but I can.
I think if it's there, we're good.
I would continue it because that is one of the rules.
Goes
Okay.
together. Okay, then perfect.
Can you restate that then?
A function is a relationship
Oh, it communicates. you're saying.
Communicates,
Communicates.
yes, that's right. A function communicates.
The relationship.
The relationship. Between inputs and their outputs.
And their outputs.
Mhm.
Great. And then what about algebraically, graphically, numerically, and tables and verbal descriptions?
I think we
We
might
should
need a
add
lot of
those.
Mhm.
All right, would you mind?
represented functions.
Okay.
Are written in function notation. With an expression. Relating inputs and outputs.
Do you think we should put an example?
Sure.
Is that sort of a show then to write in function notation?
It is not.
No.
Because if we are comparing the properties of the two functions, they will be supplied with two
Okay,
functions,
so it
and
doesn't
then
really
they
go
will
to the
compare.
language of the
There is
standard.
another standard in which they have to produce
Perfect,
function
good
notation.
distinction.
So, here, I'll jump in and write.
Oh, I would love that.
Oh, yeah, that's great. I'm at a weird angle. This is an algebraically represented function.
Okay.
F of x equals 2x.
Example.
Great.
Perfect.
Okay.
Graphically represented functions. Visualize ordered pairs. Of inputs and outputs. In the coordinate plane.
Great. Should we put an example of that?
I could draw a graph.
Sketch, sketch it graph.
Great. Okay. And then numerically in tables. I can draw a table. Okay, so numerically,
So the
Functions
standard says
represented?
numerically in tables, and then in writing the note, I would say that tables, I would just define how tables work.
okay,
Tables relate inputs and their outputs in rows or columns.
great.
We might have x and f of x, and we might have 1, 2, I forget what direction the threes go. And this is going to be 3, this is going to be 5, and this is going to be 7.
Great.
These all match
Does our standard have any supporting text that goes with it that could help us with our knows and or shows?
It does. The supporting text from the standard in Common Core says, for example, given a graph of one quadratic function and an algebraic expression for another, say which has the larger maximum.
Oh, which goes back to
Yeah.
maximum.
Maximum
So
algebra.
that
Great.
fits into, that's one of, the example from Common Core is one of the properties that we have
Okay,
identified. there.
perfect.
Great.
Oh, I love that.
We
So
did.
it makes
Sometimes it's
us
helpful.
aware that we've included it. Okay, great. And then there's one more,
Our last,
verbal descriptions.
yep, our last form of representation is verbal descriptions.
We can probably just put it on the other side with
Yeah, we
continuing
can
the
do it right
know.
here.
Yeah,
Oh, right here?
yeah, because our show's gonna go on
Oh,
the
yeah,
piece
yeah,
of
yeah.
paper,
That's good.
really.
That's true. Okay.
So, verbally described functions, that feels strange. Functions described verbally. Are passages of text using language to relate multiple quantities.
Great.
Mm-hmm.
Oh, was there more?
I'm gonna,
Oh, you're gonna,
Oh.
yeah.
I'm just gonna say, students will usually refer to this as word problems.
Oh, great.
So that'll give,
Nice.
yeah, that'll give some context for students.
Okay,
All right, perfect. Wow.
perfect.
So this is a no-dense standard.
Very no dense.
And what's difficult about this standard and the way that we measure it is that it is not realistic to measure all of the parts of this at the same time.
Mm.
Because when you're comparing two functions, you cannot represent those two functions in four ways out of two functions.
Right.
So there has to be kind of a spread. So our show, which
Is
is
that one?
very simply the text of the standard,
Mm-hmm.
I can compare properties of two functions, each represented in a different way.
Mhm.
And so it would be like algebraically, graphically.
Yep.
Algebraically, numerically in
Yeah.
tables. Algebraically, verbal, and then,
And all of the resulting permutations.
right.
Mhm.
So it becomes kind of large. very
Yeah.
fast.
We could do that.
Do you think that we would want to write those out? Probably, right? Just to make sure. So we could put just compare
Properties of two functions,
colon
yes.
and
Well, represented in a different way,
Yeah,
colon.
because this will never change.
Yeah.
So I would
Yeah.
say compare properties of two functions.
represented in different ways.
Mm-hmm.
Or two ways.
Different.
Different.
Two functions represented in different ways.
So algebraically. And can I just put dash graphically?
Yeah.
Great.
Maybe put for example.
Okay.
Do we want to list all
Yeah,
those
because the
permutations?
permutations
It's gonna
is
be pretty long,
It's gonna be very long.
which is okay.
And I
it's
think we
just-
might have more show.
Oh,
Can
So
you say the black?
the piece that I'm currently struggling with, I don't know, I might need help, is that to do this, to compare the properties of two different functions, the prevailing strategy is to extract those properties first. So if they see something like an algebraic representation, it becomes important that they are able to extract each of these properties that we described in our first no,
Mhm.
to then compare, so they can make them into the same format and then compare. So they might look at an equation or a graph, find the slope of either of those things, the rate of change, and then compare them once they have found them. And that makes me think we might need a show around
Before we get to the compare.
around getting the properties somehow.
Extract the properties from the function?
Yeah. So,
Right.
and the reason that I need help is I know that there is a standard for that. IF10 is interpreting the key features of graphs, which is not interpreting the key features of functions.
Right.
So if we end up in like algebraic and numerically, that standard doesn't cover that because the graph is not involved.
I like adding another show for that.
I do too.
So extract the
Yeah.
functions.
Mhm.
Extracting properties
Properties
Of
from the
function.
functions.
from
Yeah.
functions
In order to compare.
in order
Yeah,
to
is that what
sure.
Extracting properties.
Or just extract.
Review. Extract properties from functions.
Yeah, and so this show is very much relying on this no.
Mhm.
And so each part of that no then is going to come with what is the rate of change? What does it look like? How can you see it in different ways? How can you make them the same? And that becomes pretty dense.
Great. All right, can we just go back and make sure that we
Sure.
found everything and
Yeah.
made sure that we've covered everything? So for our one verb, we have compare.
Mhm.
That's right here.
And it became necessary for us to put one in.
Add another one.
Mhm.
Okay. And then we have the properties of two functions.
And what those are, what they include.
Okay. We discussed what a function is
Yes.
and why it's important. And then we have the algebraically, graphically, numerically in tables, and the verbal descriptions.
Mhm.
I think we have everything.
And the supporting text is an example that we have captured. It is
Wonderful.
algebraic expressions and graphs with maximum. We have
Great.
all of those things.
Well, I think we're ready to move on to the vocabulary section of the unit plan.
Yes.
Great.